Okay, hello everyone. Today I'm gonna show you about how to find shear and bending moment diagram. So, as you can see this question, will lead you to know about the shear force and the bending moment. What is shear force and what is bending moment? Here, for example, this paper is a beam. So, if I cut it vertically, this area surface will transform into the surface. I cut it like this. So the force I cut it vertically is called shear force, and the bending moment diagram. And the bending moment. So for example, this paper is beam. If I apply force like this, it will bend just like this, as you can see. And if I apply force upward, this beam will bend in the upward way, upward like this. Okay. So in order to draw the bending moment and shear diagram, first we need to know three important fundamental of it. The first one is find the reaction force. Second, internal force, and the third is shear and bending moment diagram directly. So don't wasting any time. We should consider it right now. Okay, so find the reaction force. Reaction force is the force that make the our body in equilibrium when, or it's the quantity that this force support the beam. Okay, so for example, I have one beam. So this is the beam, and this is point A. This is point B. Beyond the find the reaction force, let me introduce you about type of support. So first type of support is called the roller. Roller support. It's a notation just like this. Roller. And this, and it has only one vertical reaction force. Okay, and this, and then pin support. This notation just like this. It has two force, one vertical force and one horizontal force. And then we have fixed support. Fixed support have three main force. There's two force and one moment force. Okay, this is rotation just like this. Okay, so for example, our beam have one. This is put it roller. This is a pin at B, and then this length of the beam is 3 meters. And I apply the load of, I apply the load 3 kilonewton, and then we have 3 kilonewton that 1 meter from point A. Okay, so let's draw the free body diagram and find its reaction force. This roller has only one vertical force. And this pin has two force. FBY and FBH. I assume this FBH is left hand direction. Okay, so we have 3 kilonewton. 1 meter from point A. Let's try to find this force and this force. As you can see here, FBH have no reaction because it's in the X horizontal that have no force react with it. So FBH equal to 0. And then we just only need to find FB1 and FA1. So in order to find FB1 and FA1, basically I use the Newton law method. It's, at this exercise, let me first find the moment, sum all the moment at point A in order to find the reaction force By. Okay. So sigma MA equal to 0, and I assume that it's clockwise direction positive. Then I get 3 times 1. 3 times 1. This force times the distance, and this force times the distance minus FBY 3 equal to 0. Find FBY. We get 1 kilonewton. And then we use the upward directions equal to 0. Let me assume the upward direction is positive, and then we get this force minus this 3 kilonewton, and then plus the FBY equal to 0. FAY minus 3 plus 1 equal to 0. FAY equal to 2 kilonewton. Okay, so we find our both reaction force. So after we get to know the reaction force, I will briefly tell you about the internal force. Okay, so what is internal force? Internal force is just like the reaction force, but inside the body. For example, this is our beam. If I apply the outward force, just like this, upward force just like this, and if I cut this beam, for example, consider this is the beam, and if I cut this beam, I will see that this force have the force that react to this force in order to make this beam in equilibrium. So basically, internal force has 3 main force. One is the, okay, let me tell you again. If we cut it like this, one is a normal force. Normal force, this direction is in tension, so it means in a positive direction. And then shear force that make the beam in clockwise direction. We denote it in a positive direction. So clockwise it means very positive moment. Bend the beam like this way, like a smile face. It will positive. Okay. Okay. So we have three. So wrap up what we talked about the internal force. We have normal force, shear force, and moment. How to find the internal force? As our previous example, we already show about the reaction force. So now we will find the internal force at one point. Okay. A, B, 3 meter. Point C. Point C. So find the reaction force at point C. Also find the internal force at point C. So in order to find the internal force, first we show the reaction force, and then we free body diagram. We cut the force at point C. So let me draw the whole body free body diagram. This is 2 kilonewton, 1 kilonewton, and then 3 kilonewton. Okay, at point C, this means the whole free body diagram of the body, and then we cut it at point C. We will get this also. Get this diagram. First we have a shear force, then we have moment at point C is 3 kilonewton. Okay, so let's find the shear and moment at point C using the same method. Sigma sy equal to 0, upward positive. What we get? 2 minus 3 minus Vc equal to 0. And then we get Vc equal to minus 1 kilonewton. This minus sign, it means that Vc is in the opposite direction. So basically, Vc is the upward direction. Okay. And then we find the moment at point C. Use the moment method. I consider it in point C. Moment at point C. Sigma MC equal to 0. Counterclockwise direction is positive. We get this 2. Sorry. C is C is 2 meters away from A. Then we get this minus 2 times 2. Okay. Minus 2 times 2 plus 3 times 1. And then plus M C equal to 0. And C equal to 4 minus 3 1 kilonewton per meter. Okay, so this is the internal force at point C for this beam. So after we know the internal force, let's move to find the shear and the bending moment diagram. So basically, in order to find shear or to draw shear and bending moment diagram, so this means that we need to know the shear and moment at every point of this beam. Okay, so basically in order to find the general shear and bending moment diagram, first we need to consider the X point. So in this exercise we have only two X point. The first one X between 0 and 1 and the second one between the 1 and 3. So let me draw it free body diagram. No need. So for the first X position, and then if we cut it, it's a free body diagram being cut like this. Okay, so try to find this force and this moment. Okay, so sigma fy equal to 0, upward positive direction, 2 minus v equal to 0, v equal to 2. Okay. So we find and in okay, so let me consider this point is point C. So sigma mc equal to 0. Let me this direction is positive counterclockwise. Then we have minus 2 times x plus m equal to 0, mc equal to 2x. So the shear force, low Newton, millimeter. So basically the shear force between the 0 and 1, 2 kilonewton, and the moment force between 0 and 1 is 2x. Okay. This is our first position for X. So for the second position, so let me write down here first before delete this one in order to expand the space. Okay. So for the second position, 1 and 3. Okay, so if we cut it like this, we will get okay, draw a free body diagram. X V M V A and 1 meter. Okay, and then try to find this force and this moment. Okay, so sigma 1 equal to 0, upward positive, we get 2 minus 3 minus v equal to 0, v equal to minus 1 kilonewton, and then find the moment, sigma m equal to 0. This is the positive direction. Okay, so solve the equation. So the equation we get m equal to is equal to x minus m plus m equal to 0, m equal to minus x plus 3. Okay, so let's draw the shear diagram and bending moment diagram. Erase this. V equal to minus 1, m equal to minus x plus 3. Okay, so let's draw the shear diagram. X, and this is V, then x from 0 to 1 and 1 to 3. Okay, so 0 to 1, v is 2. Okay, v is 2. And then 1 to 3, v is drop 2 minus 1. Minus 1. 0 to 1, m equal to x, so 1 m equal to 2. 0 to 1, m equal to x, and 1 to 3, m equal to minus x plus 3. So if x equal to 1, m equal to 2. Okay, so and then it's down like this. So this is the shear diagram and this is the moment diagram.